Hello everyone. Today we discuss about the operating system important topics. First, CPU scheduling is the most important topic in the operating system. Here in CPU scheduling, first of all, what is means scheduling means to deciding which threads are given access to resources from moment to moment. This is the main. There are so many processes are available means the CPU scheduling the processes into different types and allow the process into CPU and finish the process one by one. That is the most important one. So deciding which threads are given access to resources from moment to moment. Another one is CPU scheduling is a big area of research in early 70s and many implicit assumptions for CPU scheduling is one program per user, one thread per program, programs are independent. These are all the most important to process finish a process into a CPU. One program per user, one thread per program. Programs are independent. And these are the unrealistic but simplify the problem. The main goal is out the CPU time to optimize some desired parameters of the system. Okay. So this is the main core. This is the graph of assumption of CPU burst. Here CPU burst is dependent of the process time of a process. This graph is used to decide which process is going to CPU and finishing at the particular time. Execution model. The execution model means programs alternate between burst of CPU and input output is the execution model. Program typically uses the CPU for some period of time, then does input output, then uses CPU again. Each scheduling decision is about which job to give to the CPU for use by list next CPU burst. The time slicing is the most important one. Time slicing, the process is time slicing based on the process to finishing one by one. So time slicing is the important one. It is used to finishing the current CPU burst. And then what is important in a scheduling algorithm? Okay, first scheduling algorithm there are first in, first out, shortest job first, priority based, round robin. These four types are available in the scheduling algorithm. First of all, what is important in a scheduling algorithm? Mainly, it minimizes the response time and maximize the throughput. Fairness is very high. These are all the main important thing in the scheduling algorithm. Minimize response time, maximize throughput, and fairness. We see first type FCFS. FCFS means first come, first served. This is the first type of the scheduling algorithm. FIF algorithm, it is also called run until done. Here in the beginning, this means one program runs one primitively until it is finished. FCFS means that a process keeps the CPU until one or more threads blocked. For example, P1, P2, P3 are the three processes are available in a CPU means P1 burst time is 24, P2 burst time is 3 and P3 burst time is also 3. So we want to draw the Gantt chart and compute the waiting time and the average completion time. Here there is no problem about burst time. The process won't have 24 minutes, no problem. First the P1 is successfully entered and finished the process. And the second one is P2 and the last one is P3. This is the example problem. Three processes arrived in the order P1, P2 and P3. Okay. Already we see P1 burst time is 24 seconds, P2 burst time is 3 seconds, and P3 burst time is also 3 seconds. Here, this is no problem because the first step is FCFS. So, which one is coming first, that finish the and then out. So, first one is P1. P1 is the process 1. The process 1 is the 24 seconds the process 1 have. Oh, so we draw the Gantt chart. Enter the first one is P1. So 0 to 24. Here 0 to 24 seconds the process 1 is finishing. Then the another process is P2, process 2. So the P2 entered in the 25th second. Okay. In the 25th second, the process 2 will enter in the CPU. Because the process 1 have the burst time is 24 second. So after finishing 24 second, the 25th second is started means the process 2 is entered. Already we see the P2 process 2 have 3 seconds. Burst time is 3 seconds. So 24, 25, 26, 27. The 27th second the process 2 is finished in the CPU. Then the process 3 is available in the 28th second. Okay, 0 to 24 for P1, 24 to 27 for P2, and 28th second the P3 is entered in the CPU. So the 28th second the CPU P3 burst time is also 3 seconds. So 27 to 30 P3 is finished. So overall P1, P2, P3 finished in 30 seconds. P1 for 24, P2 for 27, and P3 for 30. P1 for 24, P2 for 3 seconds, and P3 for 3 seconds. But 24 plus 3 plus 3 equal to 30. Overall, 3 processes are entered in the CPU and finishing the process time is 30 seconds. Okay. Here the waiting time is given P1 equal to 0 because P1 is the process 1 is the first process, so waiting time is 0. Another one is P2. P2 waiting time is 24 because process 1 finished in 24 seconds. After finishing 24 seconds, the 25th second the process 2 is entered in the CPU. So the waiting time for P2 is 24 and the waiting time for P3 is 27 because P2 finishing in the 27th second. So waiting time is 27. Another one is completion time. Okay, completion time means the process finishing time, ending time, that is called completion time. Already we know the process 1 P1 is 24, so completion time is 24 seconds. P2 has 3, burst time is 3, so 24 plus 3 equal to 27. So completion time of P2 is 27. And the another one is last one is P3. Already P3 have burst time is 3. So the 27 plus 3 equal to 30. Then we calculate the average waiting time. 0 plus 24 plus 27 divided by 3 equal to 17. And average completion time. 24 plus 27 plus 30 divided by 3 equal to 27. This is the first type FCFS, first come, first served. CPU scheduling. In the CPU scheduling, this is the first type of CPU scheduling FCFS. Another name is FIFO. FIFO means first in, first out. The two one is very same. FCFS and FIFO are both are same. We discuss the another topic in the next video. Thank you for watching. Thank you.